Alright, welcome to the programming lecture. So we're going to continue some more Python, and the main topic of today is going to be this thing called turtle graphics, which is really cute. You get to imagine a little turtle, he's moving, he's drawing stuff. It's really fun, but yeah, let's go ahead and get started there. And here are my goals for you, and let's go on into this, and I had that wrong. So before we get into the cool turtle stuff, let's make a simple program just to remember some stuff that we learned from before. And I do want to give you a little bit of a heads up that for now, our programs are going to be a bit simpler. We have to learn another language, of course. Things are going to be different in Python than they were in Scratch, but there will be, of course, some similarities. And I will be sure to point those out to you, so don't worry about that. I do want to say that in general, it takes quite a bit more code to write the same Python program to an equivalent Scratch program, okay? When you compare those two. It's easier to write like a graphical program with moving stuff in Scratch. But that's okay. We're just learning more. And so everything, we say that Python is a bit more low level of a language, or like closer to the actual processor of your computer, okay? It takes a bit more work, but it's going to pay off in that you're going to learn more about programming, okay? That's the whole point. So before we get to turtles, super cute. Let's do this example. Let's ask the user for two numbers and then compute the first number to the power of the second number. So what we're going to do is we're going to be like, hey user, please enter the first number, and maybe they'll type 42, and then we'll be like, enter the second number. So we'll print this, and then we'll wait for the user to type right here and hit enter. That's what input does. And then they type 2, and then it's our job to print out 42 squared. All right? And so if you want to do power in Python, you use 2 stars. It's like almost multiplication, but more than multiplication, right? That's what a power is. So I use the star operator. And so let me pull up idle. That's where we want to be working, Python 3. I don't know what version you see, but it's got to be 3 point something. Probably the same one. You want to pop up idle, okay? And this is probably a good time for me to explain where the word Python came from. Like, is their mascot a snake? Like, what are they? Does the person who invented Python really like Python snakes? And the answer is no. They really like Monty Python. So the dude who invented the language, he likes the comedy group called Monty Python. If you've heard of that, they have some hilarious movies, and everybody's following in that theme. So idle is not like, well, they made an acronym, which is hilarious, but it means more than just like you're waiting. There was one of the members of Monty Python. His last name is Idle. Okay, that's all. So let's go to powers now. So if I want something to the power of something else, I use the 2 stars. I'll be like, I don't know, 3 squared. That's 3 to the power of 2. Hit enter in the REPL, and it gives us 9. And one really nice thing about Python is if you ever learn another language, you will eventually understand why this is so nice. But integers, numbers, can be as large as you want them to be. So I can do 2 to the 42, and it'll show me the right answer. Better yet, I can do 2 to the 100. It'll show me the right answer. I can do 2 to the 1000, and it'll show me the right answer. You see that? So that's fun. Play around with that. I encourage you to do it. So now let's make our program. And so remember our game plan. First, we're going to ask the user for a number, and then another one, and then we're going to print out those 2 numbers squared. Okay? There, sorry. The first number to the power of the second number. I just tripped myself up with that 2 there. Alright, so we're going to make a new file. We're going to make a program file. So we're not going to enter in the REPL anymore. We're going to write lines of code. And remember that each line of code gets executed one after another. I can write that in a comment. Remember, this is not code. This is just a hint for the people who are writing it and who are reading it. Each line gets executed in order, just like the little blocks in Scratch. So the first thing that we need to do is, oops, gotta keep my windows straight. The first thing we need to do is output to the user, hey, enter the first number. Because otherwise, when we wait for them to enter their number, they don't know what to do. Right, we got to tell them, hey, we're about to have you enter a number here. So we're going to say print enter first number, and then we can get it with input. And that's one way to do it, but a better way is to include the prompt in input itself. So this will work. If I go and I run this, let me save it in my documents. Let's always do documents for some reason. Let's do that. And this will be called or powers, maybe powers.py. No, it already is .py, so I'll keep it like that. Save. And if I run this, run module, it'll enter first number, and so I guess we need a colon still. But actually, input as well can do this. Input itself will print out a prompt and then wait for the user. Okay? So it can take one argument. That's the first thing. You can give a string, a bunch of characters, to Python to go and print out, okay, inside of input, and then it's going to wait before it waits for the user's input. So now if I go and I run this with my F5 button, save, yes, now it's waiting for me to type here, okay? And I should have put a little space between after this colon, because right now there's nothing there. I can type 2, hit enter, and it got it, but we never used it, right? So I'll put my space. And then we need to save that number, right? So save the input in a variable, and we can call that variable whatever we want. We can call it first. Okay? So remember that equals sign. The equals sign means take what was on the right and put it into the left. The right-hand side, put it into the left-hand side. All right, so now, after this line, down here, I now have a variable that I can talk about. I can say first. I can even print it out. So let's print first. There we go. Enter the first number. 2's fine. Hit enter, and it printed back to us that 2, because that was the next line. So this was the first line, it ran, and then this line ran, and it printed out that first number to us. Okay? So that's all well and good. And notice that I had to make the variable before I printed it. Okay? If I try and do this, it all happens in order, remember. If I try and do this, I will get an error, and it's kind of funny, or maybe scary, but it's okay. It tells you where the error happened, line 8, and it'll actually say, if you can read it, here's my cursor, it's right here on this line, which happens to be line 9. Look what happens at the very bottom of the screen. Oops, I don't want that to be inverted, sorry. Don't mind me. Way down here in the corner, it tells you the line number and the column number that you're working on. So that's how you can go to that, okay? Boop. Boop. So just look down here, and it'll tell you where you are. You can go up to line 8, and it's like, oh, something weird happened on line 8. It's saying that first is not defined. Oh, and that makes sense, because here's where I define first. I give it a value, and I try to print it before it's defined. Oh, I can't do that. I'll put it there. Now I have it, because the first line is ran now. I'll do 42 now. And then I print the first. Okay? So variables are super nice because I can make a box in memory, give it a name, and I can put whatever I want inside. This might be a bit more powerful eventually than what you can do in Scratch. But variables are always important. Okay, so I have the number. I don't need to print it. I can what's called comment out this line. It's like I had it, I don't need it. I'll save it for later if I ever want it again. Now I'll do the same thing and get the second number. I'll define a variable called second, and I will give it the value of whatever input gives me back, which is what the user types. Alright, so now I guess I can print the first and then I can print the second. So now I should be able to type two things. run it with F5, or always you could do run module. A program in Python, it's called a module, a single file. It's called a module. To first number, 42, and then it prints it out, because then it runs this line. Then enter the second number. Okay. 2, hit enter, so it gets it. So input gives back that 2, that puts it into second, and we print second, and now we have 2. Alright, and now our job is to print first star star second. Simple, right? Okay, we're ready. Print first star star second. Are you ready? So I keep typing F5, but it's just run module for me. Okay, enter first number, 42, 2, and I get an error. What in the world? Unsupported operand types. Ooh, we remember that word, don't we? For POW. Stir and stir. Ooh, we know what those are too. Okay, well, what's first's type? Hit enter. Oh, it's a stir. Alright, I assume the same as for second. Oh, okay, that's right. So input gives back a stir, always. Just a bunch of characters. Not a number. I can't do number stuff with it if it's not a number. Oh no, whatever shall I do? Okay, well, the idea is we had this. We had the string 42, not the number 42. Okay, remember the difference? And so I can't say 42, string 42 plus string 2. Well, actually I can, sorry. I can't say times. And this will have the strings together. But no, we wanted real stuff, like we wanted 44, right? And so the idea is I need to make this string into an integer. I want to then make this string into an integer, okay? So here's how you do it. Maybe I want to put it here. To make an int out of a stir, you say int and pretend it's a function. So it's like a library thing, and you just give it the number that you wanted within quotes, because it's a string. And you'd be like, all right, I'm giving you this. It's not an int. Make an int out of it for me, please. Okay? So here's how we'll do it. We'll say, how do we want to do this? I want first to not be what it is right now. I want it to be the integer form of itself. You see that? And because the right-hand side always happens first, this is okay. It's going to first go and get the old first, change it into an int, and then set first to be that thing. So as of right now, I have string 42, string 2. If this line executes, it's going to set first to be the integer form of itself. Okay, that's how you convert between types. A lot of information, I know, but you'll get used to this. It's just the types really matter. They didn't really in Scratch. That was kept away from you because it made it more difficult. But now we're ready for this. Okay, so we say int 42. Yeah, it just performs type conversion. And so what's going to happen is, first is going to get replaced with whatever it was in integer form, so the quotes go away. So it's like, boop, I'm putting the number 42. Whereas this was like a stir, this is like a stir, and this is like an int. Okay? That's the idea. And so if I do this on the REPL, I can do the same thing. I can make a variable, make an x variable equals string 42, x is that, and then I say int x, and I get back the number 42 without the quotes. And if I say x equals int x, it replaces x with the integer form of itself. Okay, so now it's 42, whereas it used to be that string. Hopefully that makes sense. So we'll do the same thing for second. And we're going to get back, we're going to replace second with an integer form of itself. Okay? And yeah, that should do it. Now, at this point, because everything happens in order, remember, so right here, we can now use the star star operator with first and second, because they're both ints. Okay, so I'll go and run this with my F5, and it will print first to the power of second. Enter the first number 2, enter the second number 3. The answer is 8. You see that? And we could do some more fun stuff. We could say, I don't know, print. How do we want to do this? We want to say first, then plus to the power of plus second, and then maybe a colon, something like that. Because I wanted to print like, hey, 2 to the power of 3 colon, and then on the next line it does it. You like that idea? So I can add strings. But what are these? What are these right here? Oops. Enter first number, 2, 3. Oh shoot, now I have a different problem. Now I'm trying to add a string and an int. No, I can't do that either. I want to add 2 strings together though. That'll work. That'll totally work. So now I need to convert back. If I want to add 2 strings, if I want to add this first to a string, so I can print it out, I need to make a string out of it now. You see that? Maybe we should have saved these around instead of updating them. So now I say stir to convert it right back, okay? So that we can use that plus on strings. So types really do matter now. 2, 3. And then it says 2 to the power of 3 colon 8. And okay, we see what needs to happen here. We need some spaces. That looks better. Run it again. Enter 2, 3, 2 to the power of 3 colon, new line, 8. And we can put it on the same line even. We can say plus, you know where I'm going with this, put a space here, do the work, convert it to a string. Ooh, I like that. Now it's all in one line. You see that? It's a lot of work, but it's worth it. Oops. F5, 2, 3. Oh yeah, 2 to the power of 3 colon, space, 8. Because we do the thing, 2 to the third, and then convert it right back to a string so that I can add my strings some more. And remember that strings are just strings of characters. Just a bunch of characters, words, if you will. Okay, I think we did it. We don't need to print these anymore. Let's make a nice, clean program. And now I think we're all set. 5 to the power of 7. It's a big number, but we can do it. All right, there we go. And if you ever get confused as to what you typed and what the program is outputting, it is very helpful in that what you typed is in black, and what you printed with Python is in blue. Okay, there we go. It's like the color of a bruise. Okay, on to the turtles now. Okay, this is super cute, and I think you're gonna love it. I love teaching it. So it's all just one big metaphor. The idea is, oops, where's my mouse? There's a turtle. And that turtle's tail somehow got dipped into ink. I'm not going to throw names out. We're not going to blame anybody, but this is what happened. Moreover, the turtle can respond to commands. He can move in particular directions that we ask him to move in. And on top of that, we can tell him, hey, put your tail down, put your tail up. And you can imagine that down makes marks, while up does not. So we can have him walk. Here's our turtle. Let's make green, of course. Here's our turtle. We can tell him to walk that way, with his tail down. Boop. There's my best turtle. There he is. Put his tail down, and what's going to happen as he moves, and through the power of technology I can do this, as he moves that way, because that's his direction, he draws a line. I think that line could be whatever color we tell it to, but I think we'll start out with the default color, which is probably black. But I'll draw it blue here. And so he moved with his tail down, and he drew a line. And then we can tell him to pick his tail up for a second. Mr. Turtle, would you kindly put your tail up for a second, walk some more, then start putting your tail down some more, and draw again. Okay, so we can put spaces in between like that, because he'll respond to us. So nice trained turtle. Okay, so we can move him, and we can also control how his tail moves as well. Okay, so you can draw intricate things, and I think we're ready. So our first goal will be to draw a square. All right, make sure this is still recording, and you can search, because this is going to be another library where code has been implemented for us. You can search for Python turtle. Okay, and you'll go to the documentation page for turtle for Python 3. Okay, I don't even think the other ones are here anymore, but this is the page, and I'll even copy and paste it here for you. Okay, so I'll put it right here. Beautiful. Now you'll get to it very easily. So that's the turtle library. That's what it gives us, and our goal currently is to draw a square. And as you can see, our turtle can do some cool stuff. And this is one of the programs that, if you type this program into your idle, into one of your program files, and you run it, it will draw this. Isn't that really cool? You can change the colors of things. You can fill on the inside with yellow, apparently, and then do some cool stuff. Ooh, there's a while. Ooh, there's an if. Ooh, these might be the same. We'll learn about that soon, don't worry. That's all. So let's look at what we have here. So this is all the stuff you can do to a turtle. First you have to say import turtle, like we did with math, and then we can start using him to do stuff. We can say pen down, pen up, that's his tail, or down or up. All right, you can set his color, so many things. Let's see, set his position, or get his position, tell him to go forward, tell him to go backward, tell him to turn left, go left or right. We will get to all of this in theory. But the first thing that I think I want to do is just import turtle, and then we'll talk about motion. All right, so we're gonna make a new file. I can close this one. We'll make a new file, and I'm gonna call it, I don't know, this one will draw a square, because we're eventually going to try and draw a square, but maybe we should just do Scratch. Turtle Scratch. Scratch paper, not Scratch programming language anymore. Documents again. All right, now let's do square, because we can build it up. All right, draw a square.py. All right, so import turtle, that's the key. Now we have the, now we can use the turtle library. And remember that a library is just a bunch of code that someone's written for you. Okay? And so the very first thing we can do is run this blank program. Run module. Nothing happens. Dun, dun, dun. I think what we can do is something similar to this. But let's talk about the turtle's position right now. The turtle has coordinates. Right now we can't see him, but there he is. All right. So really, by running this program, a new screen popped up, and it's Python Turtle Graphics. And this will be different for whoever has a different size screen, but it'll be some square. And here's your turtle. He doesn't have any shape right now, but we'll give him a turtle shape, I think. And then right now he's pointed to the right. It's like an arrow. All right. So that is what you get with an empty program. And he has a position. He's right in the middle. All right. So this is like and it's a coordinate system, just like in Scratch. So he starts out smack in the middle, pointing that way. All right, to the right. Pointing east, I guess they say. Okay. So let's now, thank you. Let's now move him. So we know that he's starting out. Where is he? Starting out in a position of 0, 0. And we can get that by saying turtle dot position. Okay, this is a special way of calling functions. We say dot after it, so it's like we call the turtle's position function. Okay. We're going to use a lot of dots. It's as if library functions belong to the turtle himself. Okay. So we say turtle dot position, not position. And this gets our turtle's position. Okay, it's a special way of calling the function. We know what those look like, but now we added a turtle and a dot. That's all. Say turtle dot position to get his position. All right, so let's have him move now. Are you ready? I'm excited. So you can say go forward with the forward function. So you can say turtle.forward 25. So do we want to use our program right now? Nah. Let's close out of this. Let's rerun it. Let's say turtle.forward. And then we'll give him a distance to travel. Say like 100. All right. So please walk 100 steps in whatever units you're using, Mr. Turtle. In your current direction. All right, so I'm going to run this now. And oh man, did he walk to the right that way? And I can rerun this program, and we might be able to see him walk. No, he just walks immediately. Never mind. We'll get there. Don't you worry. It would also be nice if we had a turtle. We can change his shape. Okay? We can say turtle.shape and give it turtle. Which is a weird thing to say, but this is just the way they implemented this library. And remember, this is also a string. 2 quotes is a string, just like single quotes is a string. No problem. So we don't like the arrow. Please turn into a turtle. Alright, so this will turn our shape into a turtle and then walk forward 100 steps. There he goes, and you kind of saw him move. So here's what we'll do. Let us draw a square now. So we walked him 100 steps that way. Now we need to get him to turn left so he can go up. Yeah? So let's turn him. Let's turn him to the left. And we'll scroll to the top and see which library function will do that for us. All right, motion. Here's motion. And, oh, we have a left. What does left mean? Click on it, and we give it turn it by angle units, default degrees. So we'll say turn left 45 degrees if you want to turn him 45 degrees to the left. And there's also corresponding right, of course. So we can say turtle.left. How many degrees do we want our turtle to turn? Well, to go that way, in that direction, we need to go 90 degrees to the left. Yeah? Oh man, we have a square. We have a square now. Okay, are you ready? And also, I guess I should say, is the turtle starts with his tail down. Alright, so turn him to the left. 90 degrees. And then go another 100 steps, because we want a perfect square. Then you have been turned, Mr. Turtle. Now you're facing this way, go 100 steps. Alright, are you ready? Save, run. Ooh, he went pretty fast. We can change his speed if you'd like, but you can see how we're about to draw a square. Let's change his speed. Let's see, where's that? Dun dun dun. There it is, speed, turtle.speed. We can make him pretty slow. We can say turtle.speed, we give it a number between 0 or 10, or a string, I guess. Let's tell him to be slow, okay? Turtles are supposed to be slow anyway. Move slowly. You call that slow, Mr. Turtle? Alright, let's do it. Slowest. Super slow. That's better. Now we can watch him work. Okay. I really encourage you to just pause the video right here and complete the square. How do you do it? How do you do it? And I think you might notice, well, it's got to turn left again. And then go another 100 steps. Ooh, we could probably loop this eventually. Alright, then he's made this line. And then one more of those same things, and we're home free. Turn left again, go forward again. Boop, 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 boop. Yeah. Isn't that beautiful? So we made our square. So, complete. We drew our square. So we learned a few things, like turtle dot speed, and it's always going to correct me. Turtle dot speed, turtle dot forward, turtle dot left, and you can imagine what right does as well. All right, how about two squares now? How do we do that? So to draw two squares, I'm going to copy all the code that we had, and we're going to make a new file. This is just one squares file. All right, new file. Two squares. Save this as, not square, but 2_squares.py. All right, so we have one. Now let's get him to move away from that one. Oops. So he's just chilling right here at the end of the program right now. Let's get him to like move down here. Move 100 steps, and we'll make a new square there. So we want to move to a new starting position of second square. See that? Boop, 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 boop. Oh, his tail was down. We should pick his tail up once he finishes the first square. And we can do that with several, you have options. They all mean the same thing. There we are. No, pen down, pen up. Alright, so you can do pen down, pen up, PD or PU, or down or up. I think I prefer the last options. But you can, of course, use any of them. So we say turtle dot up. Now he's picked up his tail. And so he won't draw when he comes all the way down here. There we go. So now we have his tail picked up. So, oh man. Let's see here. we can now draw our next square, but we're going to have to ask him to put his tail back down so we actually draw his things. All right? All right, so we say turtle down. And of course, you could also say turtle.pen down or turtle.pd, turtle.down. All right. And then, well, he's sitting right here. Well, let's complete this. Let's make a square over here. How about that? Down, and then we'll have him turn to the right and make that line. All right, so let's do forward 100. Draw the second square. And now you can see how extra helpful all these comments are. Like, the whole point of them is so that we remember what we did. And oh man, is English a bit easier to read right now than Python. All right, so I want to make this square over here. So let's have him turn not to the left anymore, but to the right. To the right 90 degrees, please. So not to the left 90 degrees, but to the right. And then go forward again. Yeah. Copy. Paste. And I think you get the idea. I think you can complete this now, so I'll go a bit faster. So we just keep on copying that stuff. Go right, go forward. Oops. Boop. Boop. And it looks like, thanks to my large font, it wouldn't show all that to me immediately. Here it goes, here it goes, here it goes. Forward 100, right 90, forward 100, right 90, forward 100. Now we've got our turtle, and we've got two squares. Isn't that cute? All right. How about a triangle? Now we have to get tricky. So we're gonna have to move them in weird ways, and well, it depends on what kind of triangle you want, first of all. But let's try for some kind of, doesn't have to be equilateral. Let's try for isosceles at least. So the idea is we need some angle here that we move them by, and some angle here that we move them by. These will be the same. Back to geometry, this will be a different angle. And they'll add up to 180. Ooh, math. All right, so I don't know. How do we want to do this? Let's make it be 30 degrees in both of these. Let's make these 30. And so what does that immediately make this have to be? So we have, this better be 180 minus 60. Yeah? So let's figure out how we need to do this. This is going to be interesting. So we can start our turtle right here. Totally. We can get him ready to draw the base, and we got to pick the size of the base. Whee. And then we need to figure out how to turn him in the proper directions. All right, so whee. And it looks like I won't have time to do that, but it will be pretty darn obvious. Anyway, all right. So now we have to pick these angles. So let's make our triangle now. Whee. And we'll keep most of this stuff up here. And we'll call this triangle.py. All right, so here's the idea. Our turtle just moved 100 steps. The size of this base is 100. Good for us. Well, now we need to figure out how much we need to turn him by, because he's facing this direction. We need to turn him this way so that he starts facing this direction. What is this amount? So it's not 30. Is 180 minus 30. I hope you see that. So we need to turn him to the left. 180 minus 30. And so this gets a little complicated, but I have faith in you. Just like that. And then we can have him draw the height of the thing. And, ooh. How high should this be for it to end right in the middle? Oh darn, that's gonna be fun to figure out. Well, we can play around. We'll figure it out. And I don't know. Let's pretend we want it to go right here for some definition of here. Let's try 100 again. Maybe we do want equilateral. All right, that's almost a triangle. I think we would have more luck if we made this an equilateral. So let's do that. That would make our lives so much simpler. So we have the same length. We'll make these 100, and we'll have the same angles. Whee. How do I want to do this? Otherwise, we have to use some math, and that's not going to be as fun, I don't think. So, well, I'll keep this stuff around for posterity. Why not? But I think an equilateral will be a bit simpler, because all the things, we know how far to make the triangle. We know how far to make the turtle to make the triangle go. So this will be 100. These will all be the same angle, thank goodness. And we know exactly how far to put him. Okay, so let's see here. What is this angle? Well, it has to be 180 over 3. So 60. Perfect. So these are all 60. And again, if I want to make the turtle, who's going to be facing this way, now face that way so he can go on this leg, we got to move him 180 minus 60 degrees. Okay, that gets him over here. Yeah? All right, that'll be a bit easier, I think. Minus 60. And you can do trig stuff to figure out the other way. That's totally fine. That's better. All right, and then we can move him the same 60 degrees, 100. Whee. Hey, we have just drawn a triangle. And I do encourage you to figure out what this needs to be. Of course, it'll be this is the right triangle. It'll be fun, that's for sure. It'll be we need to figure out this height. Or no, we have 50 down here. We need to figure out this hypotenuse, but we know the cosine of 30 is 50 over h. Solve for h. Okay, so you can have fun with this, but I'll just stick with this equilateral for now. But it'll all work out, okay? And finally, I want to draw my initials, and I have a couple minutes. I think I can draw my initials pretty quickly, because this will be your programming assignment. Okay, so I'm going to do LN, okay? Let's see here. New file. Keep all this. And now we got to plan this out. So my initials are LN. And I want to draw those with a turtle. So I got to plan this out. So if the turtle is initially starting that way, I got to kind of like move him down if I want to start on this L, right? So I need to move him to the right. Boop, 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 boop. That much. I need to move him to the right 90 degrees so I can make my L. This will be initials.py. So let's say turtle.right 90 degrees. Then I'll draw the leg of the L. Turtle.forward 100 maybe. And so I have the first length of the L. Then I need to make him go that way, so it's going to be a left turn now by 90 degrees. Hopefully this all makes sense to you. It's just computational thinking sequentially. And then the L should be a little shorter, so maybe turtle.forward 50. How about that? Okay, I like that. And then we can bring him over a little bit and then start the N. Well, the first thing we need to do is bring him over without drawing anything, so we better pick our tail up. Alright, so tail's going up. And we're going to have him, he's already in the right direction, so we'll say turtle.forward I don't know, 25. We'll see if that's okay. And then we'll say turtle.down again to draw the end. All right, so now he's going to be over here. I can actually show you where he's going to be. It's going to be right here. I need to make this L, so I need to make this N, so he needs to move to the left 90 degrees to start drawing the N. Boop, boop. And then we can have the same width, or same height. Turtle.forward 100. And it's really a good idea to just keep on running, because you're going to be doing this in your programming assignment. Keep on running this thing and get to where you need to be. All right, so let's pick how we want to do this N. We need an angle here. This needs to be an angle, and this should be the same angle. You see that? Let's pick 30. Why not? Let's make it 30 degrees. Let's make it 30 degrees, and let's see here. The turtle's going to be in this direction before we try and turn him to this direction. So we better turn him, well, oh gosh, how do we get 30 out of all of this? We gotta first, remember he's here. He's facing that way. We need to get him to face this way. No, sorry, this way. All right, so we gotta, this is probably an easier way to draw it. We need to move him from here to here. And we know that this is 30 degrees. Whee. So what is this but 180 minus 30? Yeah, that's a weird looking 3. You never thought you'd be using all this geometry, did you? So 180 minus 30, we're moving him to the right. All right. Boop. And then we'll have him go forward. Oh man, I don't know how much though. We'll have to figure this out. We can use Python to figure it out, actually. And this is the kind of stuff you'll be doing. You could make it easier on yourself. You could just draw and like that or something, whatever you want. But this is going to be okay. We need to figure out how long this end needs to be. So if we want this to be 100, we need to figure out this triangle, this hypotenuse of this triangle. We have a 30 here, we have a 100 here. This looks like, again, like a cosine. So cosine of 30 equals 100 over h. So in order to solve for h, we need to say h equals 100 over cosine of 30 degrees. Oh man, I think we can use Python for this. Dun dun dun. So we can use the math library. Where's my shell? Import math. And, well, we better look this up. Python math. Because cosine is originally in radians. We need to convert that to degrees. We can convert from radians to degrees using degrees. Oh, it's all coming together. We need to go. All right, whatever. There. Let's make our h. H equals, are you ready for this? 100 over math.cosine, math.cos of 30 degrees in radians. So I'm going to import turtle and I'm going to import math. And I can say math dot radians to take my 30 degrees and make radians out of them. Yay, convert angle from degrees to radians. All right, hopefully this makes sense. This is 30 radians now. Cosine of that will work and make 100 divided by that. That'll be my h. And I can tell my turtle to go forward by h. Moment of truth. Oh yeah. Now we gotta move him up and move him to the right. Or sorry, to the left and move him up and we're done. and we know it's 100 up. So I do want you to walk through this code, understand why it's working, and then you're going to do this. All right, so I'm going to stop now, write up your assignment, and be right back. Okay, just briefly, your programming assignment is going to be pretty much this. Draw your initials, but also draw your graduation year. So I want you to draw your initials first, and then the year that you intend to graduate. So for example, LN20 is mine, and you don't have to use these fancy angles on the end if you can't figure it out. You can just make a bunch of straight lines with 90 degrees between them. That'll work too. So here's an example of just the initials, but of course don't forget to write those 2 digits somewhere else. Maybe you can make them a bit smaller, be like LN20, boop, just like that. So please upload a video of your code working. It can be really short. Yeah, just the same as we've been doing it before for Scratch, but now for Python. I'm excited to see if any of you do any fancier things like change the color. It's all going to be in this page, all the cool stuff, and I encourage you to try this out. But with that, I've said everything I needed to say. Good luck, and also this will be due in 2 weeks because I don't want to have this conflict with the midterm. Okay, with that, I'm officially done, so I'll see you later.